and then I'm going to Disney.
medical conference. Oh, I liked the thumbnail on the WRSN. No, that's Suncoast. PSOA today.
Oh, was
of
that
you.
yours?
It was you.
Oh, God, no.
Pardon the interruption. Can I please have Olivia Kahn to come to guidance?
Okay.
Thank you.
All right. So doing the warm up, the integral test. All of these are integrable. So just because one of them looked really hard to integrate didn't mean that it was the one that you would choose. Doesn't happen. It's the fact that it's not decreasing or positive or continuous. So which one is not decreasing? Because there's one of them I think that's pretty obviously not decreasing. C, what is C doing? Right, it's oscillating. It's just bouncing between numbers forever. Guidance. Okay. So this one is oscillating. Oscillating. So it's not decreasing, so this is the only one that you can't do the integral test with. Not because it would be hard to integrate. I mean, it would be, you'd have to do integration by parts, but because it's oscillating. All right, on 2, which of these is a divergent series? What is a harmonic series?
P is 1.
Well, P is exactly 1. So then it's these two, which is C. Oh my gosh, we got another pattern happening, I think, friends. All right, on this one, we're going to find the sum. It's probably going to be a geometric series. Then we look at it, and oh my gosh, it is. So then how do you find the first term? Graham.
Plugging 1.
Why are you plugging in 1?
Because n equals 1.
Okay. So if n equals 0, what would you plug in?
0.
Okay, just checking. So we got a is 5x squared, xy to the 1 minus 1, which is 0. So then you have 5x squared times 1, because number to 0 is not 0. Number to 0 is 1.
Yes.
We can kind of already pick that it's C, but just in case you don't remember, you have 1 minus r, so you're going to have 1 minus r is xy. I was kind of like trying to look through to see if any of these could have like been cool and like reduced or anything, but no. This is the common distractor because a lot of people, I think, find it confusing that we have so many variables in this problem, and they start putting in like 1 everywhere that they see a variable, and they're just like, A is 5 because I'm putting 1 with everything, and that's not it. It's just where the n was. Okay, then going up to 4. Nth term test for divergence. When we take the limit for A, what is this approaching for arctan? Pi over 2. It is not oscillating. It is, you're thinking tan. A lot of you kept thinking tan. This arctan is going to a horizontal asymptote on either side. This is one of College Board's favorite thing to approach to infinity, just so we know. And then C is another common wrong answer for this. Why is C not correct? Yep.
Because you have to multiply out the top.
Right. So C, the limit for this one is 1. It's not big bottom. The top is squared and the bottom is squared. So it is not equal to 0. Okay. B is big bottom. This limit would be 0. Yippee. Diverges. Oh, wait. Doesn't diverge. Yippee. Inconclusive. And then what about D? D's limit is infinity. So this also would not equal 0, so it would diverge. Zeppelin? I would not classify. Oh wait, B. Sorry, I was thinking C.
Like the convergence. I guess I saw that before.
Yeah, it is a convergent geometric series, so that's another reason why. But if you were like, it's telling you to do the nth term, so it's just the one that like nth term would not be conclusive for. But yeah, it is also converging geometric series. All right, so I did the most in second period. There's such an easier, probably more realistic way to have done number 5. And I'm going to do it first that way. But I do want to point out a rule for series for you because it's something that as we get into the rest of Unit 3, that is helpful to know. So things to point out about series. When I'm adding and subtracting series, I can only add and subtract them if their index, so the starting number, is the same. Are these indexes the same? Obviously, no. So in order to make them be the same, I can find first plug in 0. So the first term here would be A. And then I'd have plus starting at 1. This is a n equals 0 term. Starting at 1, then I have A times R to the n minus, again, I don't think many of you thought to do this because you didn't know this rule, but I think that it's like worthy of starting to like kind of let you know how series work. So what's happening now in this part right here? They cancel each other out and you're just left with A. But the way that I think most of you did it was seeing that was a geometric series and doing the geometric sum formula. And so then you had A over 1 minus R. And then the other term was, when I plugged in 1, you'd have AR, right? Oop, that was a minus sign. Hello. AR. And then over 1 minus R. It's so funny to me how you guys can get so good at calculus and be so bad at simple things. So when we're adding these together, they have common denominators. Can they add together? Yes. So let's add them together. Wow. And then what do they have in common in the numerator? And then you're like, 1 minus R is left. And well, what do you know? They cancel out and you get A. So there's another way that I think you could have done it. Graham?
Do you want to hear the way I did it?
Sure, I would love to hear the way you did it.
I plugged in 0 for the first one, and then I saw that it was 1 for the second one, and I was like, well, if you continue to keep going, it's the same sequence, but this one has 0, so then you subtract.
Right, which I think is what I did here.
Yeah. Except I did it without...
You did it with like logic instead of like actual like writing.
Instead of knowing how geometric sequences work.
That's how all series work. You can add sigmas together if they have the same index.
I'm so proud of you.
I'm not, dude. You don't stop.
All right, on 6. Which of the following is not a, which of the following is a P series? So I want to figure out what's not. So what's wrong with A? It's oscillating. P series cannot be changing signs. Okay, then we're looking at C. What's wrong with C? The numerator's changing, so that's bad. It's B, right? Because we have like 2, I think the pattern is n squared, 1 over n squared. What's wrong with D?
You're squaring the
First, the previous term.
You're
Mhm.
squaring the previous term.
Or, no.
Oh, you're dividing by
It's a
4.
geometric series.
You're dividing by what?
Yeah. You're multiplying by a 4th each time. Yeah, it's to the 0.
Oh, yeah, that makes sense. Never mind.
You're so awesome. All right, on 7.
Yeah, the
He's just so cute. Like his inside thoughts are always outside, and it's so funny. I like to hear his thought process. I enjoy it. It's cute. I wasn't trying to be mean to you. I think it's cute. They're being mean. All right, so the integral test question. If it's a multiple choice question, do you think you have to actually do the integral test? No. What test did you do instead? I did the limit comparison test, and I compared it with n over n squared. Okay, and is it diverging? Is our comparison diverging? Yes, this is diverging. And then if you did the limit comparison, you'd have n squared over n, and then you have a little limit, and it equals 1. And you're like, yay, that's positive and finite. So therefore, the actual series also diverged. If you integrated this, you would have said u is n squared plus 1 du is 2n dn, and you would have gotten 1/2 ln n squared plus 1. Take the limit, b going to infinity. Where's, sorry? Oh no, 1. Okay. And then ln.
No, when you integrate, it's 1 over u squared.
No.
It's 1 over n squared plus 1.
It's not.
Buddy.
It's not.
No,
I think you did the derivative.
we made u
Get him out.
n squared
Get him
plus 1.
Get him out.
Because you
Leave! You did the derivative. Yeah. So,
Oh, I did. Get out.
so on 7, I think that what is going to screw you up would literally be doing the integral test. I think the integral test actually is going to confuse you on this, because what did the limit with the integral test equal? Infinity, right? So if you did the integral test and you just like didn't read exactly what they were asking you, you would have picked D, and it's not D, because it is not asking you about the limit of what you integrated. It's asking you about the limit of the original thing. I don't know why. I don't know why it's asking that, but the terms of the series, so it's taking the limit of the series. What is the limit of the series? 0.
Bro, it's not right. He's still arguing with A is right.
It was definitely diverging, but the limit being 0 was about the original series, not about the integral.
Halfway why it's diverging. Yeah, it's okay.
Well, when you integrate it correctly, instead of taking the derivative, when you integrate it, you get ln.
Yeah.
And then you're doing the...
Oh, yeah, no, I get it.
Okay, so glad I could help you with that.
I forgot to.
And then you're doing the limit, which is infinity.
You're the last person we talked
Merry Christmas.
I didn't even hear what he said.
I don't know. It's not worth it. All right, let's do, get out our notes. Today's lesson should be fast.
I thought this was the one you didn't like.
That's actually Tuesday's lesson. Look at, it's my self-portrait. It's me. It's so cute. Do you like my wig?
Wait, I love it.
Did you do it by yourself?
You should like start doing your hair like that.
He wants to do it by himself.
For Halloween.
We have the same nose.
Please wear that.
Leibniz. Only my students would understand. And you still don't really understand. You're like, I don't know, she's some old man, some old mathematician.
Your son would be stars for
If I came out with like all of the puffy thing here and the big wig. So
I'd be
Leibniz,
entertained, actually.
I think my costume is better than that. I'm not telling you. It's a secret. You'll have to find out on Friday. All right, so alternating series test for convergence. So what do you think this series test tests for? What do you think it's not testing for?
Divergent.
Very good. So if it doesn't follow the rules, it's not diverging. What is it? Inconclusive. If it follows the rules, it's converging. So first, let's identify some alternating series. Alternating series is -1 to the n. It can be -1 to the n plus 5, -1 to the n plus 100. What it can't be is -1 to the 2n or -1 to the 2n plus 1. Why can it not be to the 2n? Right. What is 2n really always going to make the numbers be? Even. When we do 2 times a number, like 2 times 3 is 6. 2 times another odd number, always going to be even, right? So like when you double something, it makes it be even. So -1 to an even power is always equal to 1. Then once we have made a number be even, so we've made it be even by doing 2n, and then we add 1 to it. So like 2n, so 2 times 1 is 3. plus, no, 2 times 1 is 2. Plus 1 is 3. So you're forcing the even, and then adding 1 or subtracting 1 will make it be what? Odd. So -1 to any odd power is going to be -1. If it's always positive or always negative, it's not alternating. It's just always going to be positive or always negative. So these are not alternating. Another tricky alternating is saying cosine pi n. How is that an alternating number? If I'm saying like sum going from 0 to infinity. Right, let's expand it out a little bit. What's cosine pi at 0? 1. And then what's at pi, 1 pi? -1. And then at 2 pi?
1.
And then at 3 pi? -1. And it's going to oscillate between positive and -1 forever. So this is College Board's like favorite, and mine honestly, way to ask you about an alternating series. Having cosine pi n. Another one that you don't see as much is doing sine 2n plus 1 over n, because this is doing the same thing, not over n, over 2, sorry. This is basically doing the same thing, but for sine. I don't see this as much because it's just like kind of ugly. It's not so cute to write it this way. So, this is also doing like the same shtick, right? Like it's going, when I have it pi over 2, sine of pi over 2 is 1. Sine of 3 pi over 2 is -1. 5 pi over 2, 1. 7 pi over 2, -1. Yeah.
This is the same for any trigonomic function.
No.
No. No, I was
Tangent, you could do a tangent at like all the odd pi's over 4, and that would give you between 1 and -1. Yeah, like they would alternate if you have a specific number, but these are like the most common ones that we'll see is sine and cosine. Secant, cosecant, I guess that you could do, yeah, you could also do a secant. You're right. Okay, sorry, I retract it, William. You could do it for all of them. Good job. Yay. Now, I said it so meanly too. So alternating.
question. I wasn't like trying to state something.
So let's do, instead of saying AN, I don't really like that it's called AN because I think that's going to be confusing. Let's call this BN. And maybe I'll actually remember to edit it on my notes. We'll find out. Because the whole entire series has been how I call, what I call AN. So then all of a sudden it's AN times -1. I feel like it's going to be weird. So taking, like, I think this whole thing, I think of this whole thing as being AN, including the -1 to the n. That's the whole series. But the part that we're testing right now is the part that is not the alternating, the thing that's making it alternating. It's like everything but the -1 to the n. So you take the limit. Do you see how, I just want you to think about another test that we've used that would be a limit as n goes to infinity. What's that other test? The nth term. What was that testing for?
Divergent.
Right. And what could it not be? This is literally like the opposite of the nth term test for divergence. This is only testing for convergence, and this is saying it can equal 0, and only if it's an alternating series. So only alternating series when the thing that's not alternating is 0, the limit is 0. And what is this part? What do you think this part's telling you? Decreasing. So this part, as long as we have the limit is 0 and it's a decreasing function, then it would be converging. If you get either part of these to not be true, then it's inconclusive. It's not diverging.
The limit has to equal 0.
Yeah. Why this is the case is because think about functions that the limit would be 0. That means that they're bigger in the bottom, so and they're decreasing. So as we're getting closer to infinity, even though it's alternating, the numbers are going on opposite sides of the x-axis, but getting closer and closer and closer to being 0 without actually ever equaling 0. But they are getting really, it's like that stuff we did on the first day. So basically, converging series look like this, of this unit. So this is like an alternating convergent series because it's big bottom and it would be going to 0 and it's decreasing.
So for the ones that we're testing that follow the test, that's what they all look like?
Yeah. If they don't look like that, then they're not passing the test.
But can you just do a normal limit comparison test and it'll tell you that it has a limit at like whatever, like 0 or something?
No, because in the limit comparison test, the numbers have to be positive.
Oh.
And this one's negative and positive and negative and positive. Like part of the limit comparison test is the whole series is positive. Graham.
Why is the theorem 2.7 but 1 is 3.6?
It's 3.6.
Okay.
Okay, so some important notes. Let's fix this too.
Oh, thank you, Ms. Russell. I was worried.
Yep, I could tell.
3.8.
You would just stop on the fries.
I did.
Mhm.
3.8. Why
3.8.
do you skip 3.6 and 7?
Mango, mustard.
This is like really a college level course.
I really wish you would act like you were in college. All right, so alternating series test only proves convergence. We are going to go to 3.8, and we're doing it on Tuesday. So we're going to be doing the convergence, conditional and absolute convergence. This is the only one that has a conditional convergence. That's future you problem. Today we're just trying to figure out if it converges or not.
Thank you.
Yes, you're so welcome. So on here, this is Bn. It's the part that's not the -1 thing. So step 1, take the limit.
It's gonna be -1. It could be like -5.
It could be a -5,
Okay.
but that's going to also make it big, like change the numerator of the thing too. But, because like if it, no, it's going to be -1. Because like -5 is going to be like 5 to the n in the numerator. Like if it's like -5 to the n, it's like -1 to the n times 5 to the n. Like this is actually a geometric series,
Okay.
which would be diverging. You get what I'm saying?
Yeah, I see.
Okay, so going to infinity, 1 over n. What does this equal? 0. Because it equals 0, we can continue. If it didn't equal 0, then you stop. And you're like, inconclusive, got to do something different. Yep.
The exponent's n plus 1, which you said would make all of them negative. So how is this an alternating series?
I did not say it's a 2n plus 1 would make them all be negative.
It is.
No, it's n plus 1, not 2n. I'm not saying to the power of n plus 1. I'm saying to the power of 2n plus 1.
Is that, yeah, is, yeah.
Now we're trying to figure out, is it decreasing?
Yes.
It's not sufficient to say yes. You could, but you don't need to. You have to do, there are 3 things that you can do. So here are the 3 ways that you're going to do whether or not it's decreasing or non-increasing. My favorite way is to do the algebraic difference, which is really just saying, is the next term less than the term right before it?
Yeah.
So you have to show that though. Let's do an plus 1 compared with an. We have anywhere that there's an n plugging in plus 1. It is not sufficient to just plug in 1 and then plug in 2. Or plug in 2 and then plug in 3. Because the pattern needs to be holding that's decreasing much bigger than right at the beginning of the series. You have to check like further in. So it has to hold for everything. All right, when we're comparing 1 over n plus 1, and 1 over n. The denominator on the left one is bigger, right? So then the entire fraction would be what? Smaller. So compare denominators. Doing the algebraic difference is easy when the numerators are the same. When the numerators are different, then you want to do the algebraic ratio thing. Zeppelin?
Why did we put it over, like, or like under 1? Why did we put it as a denominator?
Because bn was 1 over n.
So if bn was,
N,
yeah,
then it wouldn't have passed the first part.
okay. But
It's
like,
always going to be like big bottom
okay.
if you can do this test. Yeah.
Why is it less than and equal to? Like if it was equal to.
Because like at like one of the terms is probably going to be matching, but in the future it's not going to match. Yep.
I'm slightly confused. Because,
Okay.
So I understand that the terms are decreasing, like as we're going on, like the bottom's getting bigger, so it's decreasing, but aren't we adding them?
Yeah.
So,
But we're adding them, and are they going, as we add the numbers, is it getting further apart? Or are the
Okay.
numbers that we're adding getting smaller and smaller and smaller and smaller and smaller?
oh, and because it's oscillating, it's going to zero. Yeah. Okay. I got it. I was thinking that they weren't oscillating, so they're just going to continue to add to each other.
Right,
and that
because if they weren't
would- yeah.
oscillating, then it would diverge.
Yes.
Yes.
But yeah. Gotcha. Thank you.
Okay, so because of those two being true, then we would say that the entire series, AN, or you could like write it all the way out if you're worried, converges. And it's converging by the alternating series test. AST is an accepted abbreviation for the alternating series test. So when College Board has an accepted abbreviation, what does that mean? Right? Use it, and they love it. They heart it. They heart hands, and they will be asking you about it. So this is probably like their favorite one. I don't know why. It's not mine, but this is their favorite thing to ask. No. AST is like the only one that they are like, they'll like literally on their scoring guideline have AST. And I'm like, you were typing this. You couldn't write like alternating series test. Like, really? Try to be. Zeppelin, did you have a question?
I was gonna ask, like, if you could do it for other tests, like limit comparison tests, you couldn't write SLC to
Mm-mm.
they should, like, they really want to
Yeah.
they'd be really annoying.
Mm-hmm.
That's really frustrating.
Wait, so this is the only one you can abbreviate? If I write GO series,
That's that's like you're shortening the word. You're not like making up an acronym for something.
if I write GS, every time
They're like, huh?
wow.
Your gastrointestinal system? What are we talking about? Okay, B should be fast. Yeah, this one is, the limit is,
Thanks, inclusive.
Good job, Graham.
Thanks, man.
so because the limit was not equal to 0, we would say it's inconclusive.
Thanks, man.
What other tests would you do to figure this one out? Please don't ask.
Could you use the
Great question. What test could we use? The nth term test for convergence or divergence. Ooh. The divergence one would work. So do the limit of the entire series though. So what is the limit of the rational function going to? Like this part? 1. And then what would this one bounce between? So this is going between -1 and +1. It's oscillating. Mm-hmm.
Divergence.
So you're saying it's oscillating, and that means that's not equal to 0. So because the limit of the entire series doesn't equal 0, then the series diverges by nth test for divergence.
So if there's an alternating series and it doesn't equal 0 by AST, we can say they're divergent.
You have to show that limit of the whole series.
You can't just like pull that.
No, you can't be like, let me hear, out my booty. Here we go. You have to actually show the work that matches the test.
So also they
They're kind of synonyms. But the fact that it's alternating doesn't just mean that it's like diverging. It is oscillating between the numbers 1 and -1 exactly. I think
And
of,
because it's exactly those two numbers, that's
Right.
why it's
right,
So
where the other one that we did before is alternating. It is oscillating, but it is alternating
between different numbers that are still here.
that it getting smaller and smaller and smaller until you're basically adding on 0 at the end. All right, the other thing that, the other way to avoid doing the derivative, because some of these, like if you're looking at example 2, are not great for doing the derivative. Like how do you do the derivative of a factorial?
How do you?
You cry. Instead, you can do the algebraic ratio, which basically shows that if the next term divided by the term before it is smaller than 1, so making like a fraction smaller than 1, then it's decreasing. Let's do this example. I'm going to show you in both ways. I do want to show you how to do the algebraic way because we're about to start doing the ratio test, which is dealing with factorials. So we want to be able to do that well. So what is an equal to, or bn equal to on this one?
1 over 2n.
What? No, don't do that. So, factorial is a 2n factorial, just so we know, does not equal the same thing as 2 times n factorial. In a 2n factorial, every single n is being multiplied by 2, whereas this is equal to 1 over 2 times 1 over n factorial. Like the doubling is not happening inside the factorial. This is much bigger. Mm-hmm. Yep.
Regarding factorials, do we like not need to know much about it except what's
You know, what else do you need to know about it than they're multiplying? They're just like getting bigger, 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 bigger.
Does it multiply every previous term?
Yep.
So
Index to 0.
Until n gets to, it's not gonna multiply by, because then it would be.
that's what I meant.
Yeah. All right, so let's take the limit. If we take the limit as n goes to infinity of 1 over 2n factorial, is this big on the bottom? Yes. So we keep going. I'm going to show you how to just like think about comparing them first. So we have 1 over 2n compared with 1 over. Here's the thing that you guys are going to screw up. It is not compared with 2n plus 1. We are substituting in n plus 1 where there was an n. And what was happening to the n? It was being multiplied by 2. So you can't just put a plus 1 next to it. It is being multiplied by 2, so that comparison needs to be multiplied by 2. So it's essentially 2n plus 2. Very different than, not very different, but it is different than 2n plus 1. And that's why it's so much bigger, because now you have 2n plus 2, and then 2n plus 1, and then 2n. You have like way more terms happening than this, than having 2 times n factorial. All right, and which one's bigger? I don't know what that means.
2n plus 2 is the first one.
The denominator on the right is bigger, right? So then the left is oh, sorry, wrong way. We are decreasing. This converges, but let me just show you how to deal with this algebraically. Because sometimes you're having a hard time telling what's going on. So let's do an algebraic ratio of comparing an plus 1 over an. Because a couple of the things on the classwork, it's going to be easier if you do the algebraic ratio than this comparison. I think that comparing, for some people, this is all you need and you get it and you can confirm that it's decreasing. And other people are like, I don't get why we know this. So the next term would be 1 over 2n plus 2. And then we have 1 over 2n factorial. Multiplied by the reciprocal, I get 2n factorial over 2n plus 2. When we're dealing with simplifying factorials, it's kind of a good practice to expand out the bigger factorial because eventually it's probably going to cancel with a smaller factorial. So which one's bigger? The bottom. So I'm going to keep the numerator the way that it looks. And then the bottom, with factorials, we're doing wherever it starts and then multiply by one less term. So what would be one less? Then what would be one less than that?
2n.
And then look, wow.
Oh. Wait, what is this for?
This is the algebraic, the seeing if it's decreasing just like in another way.
So we don't need that.
Is this gonna be less than 1?
Yeah.
Yes, so it's decreasing. This is just like another method to show things are decreasing. Also, it's good prep for when we do the ratio. Yeah. So this one is converging by AST. Okay, I told you it was fast lesson. That's it. So today we're gonna do all of the classwork problems. Every person in second period got a sample.
Yeah, I'll leave them
So
out.
this is not okay. Oh, if second period.
I'll eat
I think it'll be fun.
If all the
If all we got
yeah, you can do mine. That's fine. It's probably the first sample you've ever done. Okay, so this one would be amended down over next.
You guys are like, oh my god, it's so hot in here. And now it's so cold. You guys are like Goldilocks. I can't, why can't